Hello everybody, I will start my today another live coding session. So in my today's video, I will solve this question, binary tree maximum pass sum. I've already posted the videos about this question twice, so today I will go for real quick. So binary tree maximum pass sum. So a pass in a binary tree is the sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. So a pass is a kind of the connection, a sequence of edges. A node can only appear in the sequence at most once. Yep, so I cannot visit any node twice. And note that the path doesn't need to pass through the root. Okay. A path sum of a path is the sum of the node values in the path. Given the root of a binary tree, return the maximum path sum of any non-empty path. Okay, so for example, in 213, the path sum should be 2 plus 1 plus 3 is 6, but also this can be only 2, or only 1, only 3, or 2, 1, which is 3, or 1, 3, which is 4. But out of them, 6 is the largest, so I return 6. Okay, so let me clarify. So let me go with interface. So in this question, I'm given a root node, which is the tree node object. And I will return the max path sum, which should be number. Okay, good. And also I will check some constraint. So the first thing I can say is root.var can be negative or positive or 0 or positive only. And I will check this and I find this can be any of negative, 0, positive. Good. The next thing I'd like to confirm is how many nodes there are in the tree. It can be an empty tree, or at least there is one node or some other constraint. I will check it, and I find that the number of nodes in the tree is at least 1. Okay, so I can say root is not null. The last thing I'd like to confirm is a sequence, a path, has to have at least one node, or it can be an empty path, and I will take the path sum as 0 in that case. So that's what I'd like to confirm. I can't find it, so let me think. With this, so I will define the path to have at least one node in this question. Okay, so I've clarified some things now, so I will see an example. Okay, let me go with this. In this case, maximum path sum should be 859, which is 22. Yeah. If I include this -2, it becomes maybe -259, which is 11. No, smaller than 22. 859, -15, obviously smaller than 22, so it doesn't work. So 859 should be the largest maximum path sum. Okay. With that being said, I will think how I can find it out. So I think when I think of the past sum, there is exactly one node which positions as the highest position. Yeah. So, for example, 859 case, the highest node is 5. Let's say the path -259, highest one is -2. So I think I will think of I will take a look at each node and consider that it is the highest node in the path. And I will think every possible path which has the current node as the highest node. Yeah. So when I think of that, the kind of this local maximum path sum should be this one's value plus the kind of path which begins from 8, in this case the left child, and goes down. I can't go up because 5 is now separated and considering as node bar here. So node dot left, how to say, path sum from node. Path sum going down from node dot left. And the same way, node dot right. Yeah. So for example, this case, if I take the node 5, the path sum going down from node dot left should be 8 only. So this should be the one. Or maybe I can throw this away in case this is -8. So I have to take the maximum. Yeah. And when I take a look at the right chart, the maximum path length, maximum path sum, which begins from node 5 to node 9 and going down is 9. Yeah, only 9 is the largest. Because if I take 9, -10, it becomes -1, which is smaller than 9. It is the maximum. In this way, I guess the local maximum path sum. Yeah. So now I get the local maximum path sum for each node. So in the end, I return the global maximum path sum, which is the maximum of every local maximum path sum. Okay. I think this is the brute force approach, even though it's already smart enough. So for the time complexity, there are n nodes in line 20. So I will assume that there are n nodes in the tree, and in line 20, I traverse each node. And for each, I have to find the global maximum path sum going down from node to left. I'm pretty sure I can find it with recursion. So yeah. It should be O of n time for each. So it should be n times n, which is n cubed time complexity. Yep. So this is the brute force approach. So I will try to optimize this. There is a kind of redundant work I can save, which is I'm calculating the path sum going down from node to left. So I'm pretty sure when I think of the path sum going down from node something, I can easily, sorry, let me rephrase. If I try to know the path sum going down from some node, this can be, broken down into two problems. The case when the path sum has only this node, or going left, like 5, 8, or going right, like 5 and then 9 and blah, blah, blah. So when I start from 5, oh, and the thing is that I said 5, 8 case, and when I start from 8, I do the completely the same thing as the case of node 5. This is obviously the recursion. So I can recursively solve this question. What's the path sum, maximum path sum going down from some node? So yeah, I can use the recursion here. And with the recursion, in line 25 and 26, this takes only the constant time, which means that the time complexity is now optimized to n times 1, which is O of n. Right? So the approach, ideally is max path sum going from can be solved recursively. As I said, node.left, node.bar only, or node.left case and node.right case. And I do the recursion here. Yeah. So this is what I mean by the recursion. So yeah. For space complexity, let me do it later. But at least I can say I can do the recursion, and this logic, line 22 to 27, takes, line 23 to 26 takes only the constant time by using the previous result. Okay, so let me work on the implementation. Yeah, and I think what I can do is, inside of this method, I will update global max path sum. So recursive function does two things. The first thing is return the max path sum going down from the given node. Also, the recursive function updates the maximum path sum, which goes through the current root node. Okay, that being said, let me get started with the implementation. So Number 1 returns obviously the find maximum going down from root. And number 2, update global max sum. Yep. So by the definition of the path, which has at least one node, and also from the constraints that the root of the bar can be negative, I have to initiate this I have to initiate global max path sum with negative infinity. Otherwise, say if I initiate with 0 and if all the nodes in the tree is negative numbers, it's wrong. I end up returning 0, which is not true. So this is the main method. Okay, so now I will implement the helper method. So maybe I start with the edge case. No, base case. Let's say return. Let me think it later. But if root is not known, what I can say is, first thing I try to do is I call the find max sum going down from root dot left and to root dot right. And first thing I will do is solve this question in line 23, max path sum. So maybe I can name this to left child sum, right child. Okay. And whatever, local max path sum should be, at least I have to include root max. So I just have to do 24 to 26. Okay, and I will update this one. Okay, so now we're done. So I've done the second task, update self.global max path sum. Okay. And now I try to return max path sum going down from root. So it should be, as I've written here in lines 35 to 38, I can write it in this way. Root bar plus this, or so what I can say is root only, or root plus left child path sum, or root plus right child path sum. I can write it in this way. Yeah. Okay. I think this is it. The local max path sum should include root, and it can go left and also to right. Both of them can be included, but for the max path sum going down, I can include either of left or right path sum going down. Okay, so that being said, I will handle the base case. So if root is known, what is expected to return is basically left child path sum and right child path sum are used in this way. I think I can return 0 here. Or maybe mass negative infinity is fine. In either way, it is thrown away. I mean, default to 0. So let me quickly write it down. So this is the case when currently it has node 5 and node 3. So let's say I'm at here. And what is expected to return is, so I mean, the parent, caller recursive function uses this return value. So if it returns 0, which means that, which makes no harm. So yeah, I think it is fine. But maybe for clarity, I should return mass infinity. Yeah. Which means that this number is very, very small. I should definitely not include this result in the parent recursive function. Yeah, and that is actually done by taking the max 0 and that value. Yeah, so I think this makes the intention more clear. Good. Okay, so now let me dry run my code. So I will go with maybe this case. The point is that I try to ignore this negative one. And also one more case. So every number is negative. In this case, I try to make sure that I return the biggest negative number. Okay. So this case, 1, negative 1, 3. So firstly, max path sum is called with node 1, and global max path sum is initiated with negative infinity, and find max path sum going down from is called with node 1. Then I return this one in the end, global max path sum. So in this recursive function call, so find, yep. Firstly, root is unknown, so I go to line 83, and left child path sum should be, I call this again with root.left, which is -1. And for the right one, I call this with node 3. So I have to calculate it first. So for this one, root is not known, so I go to line 86, and which is find max sum going down from node known. So this should be mass infinity. Sorry, negative infinity. So I call the recursive function again, and in line 84, minus infinity is returned. And the same thing happens for -1's right child. Yep. So both of them are now negative infinity in the recursive function call of this one. So in line 90, I get root of the bar, which is -1 plus 0 plus 0 is -1. So now global maximum length, global maximum max path sum is updated with -1. Then I go to line 96. Oh, wait. In line 96, I did it. Then in line 98, I return root of the bar -1 plus maximum of 0 or minus infinity or negative infinity, which is 0. So return 0. This should be 0. Okay. So far, no, -1 plus maximum of 0 or negative infinity or 0 infinity, which is -1. Yeah. So far, this is as expected. Okay. So I've covered this helper method, and I'm pretty sure it works well. So let me speed up from here. So when I call this with 3, because this is a Reef node, this does almost a similar thing as -1 node. So this and this, and local max path sum should be now in line 94. Root of var is 3, so 3 plus 0 plus 0 is 3. So global max path sum is updated with 3. And whatever return is, root of the bar, which is 3, plus 0 or negative infinity or negative infinity max, which should be 0. So this returns 3. Okay. So now I've corrected the, parent result in the recursive function call, line 54. I can calculate it. So now what happens is that local maximum path sum should be 1 plus maximum of 0 or left child path sum -1 plus maximum of 0, 3. So this becomes now 4. So in line 100, global max path sum is updated with 4. Good. And in the end, in line 102, I return root of the bar, which is 1 plus maximum of 0 or -1 or 3. So I return 4. But actually, I don't use this result. Okay. Anyway, what I've found is this main method in the end returns self.global max path sum, which should be 4. So I passed this test case. Great. Okay, so one more thing I have to take care is this case. -2, -1, -4. So I don't cover this. I'm already pretty sure of this code. Yeah. I confirm that if the path sum going down, return from the recursive function call is negative, it is thrown away. I could confirm it. So I don't do this test case. Yeah, but if I'm doing the development in the daily job, definitely I will write this test case. Yeah. Anyway, I will submit my code. Good. Okay, accepted. So I will do the space complexity analysis. So basically, the only data structure I used here is the recursion stack. And in the worst case, the depth of the recursion can be n. This is the case when the given tree is like the linked list. There are n nodes, and all the nodes are connected as the left child of the parent node, for example, or maybe right child. So in that case, the depth of the recursion should be n. So I need the O of n space complexity. Yep, that's it. Okay, that being said, let me quickly wrap up my test coding practice. So today I solved the question binary tree maximum pass time. And in this question, I'm given the tree, binary tree, and my task is to find the maximum pass time of any non-empty paths. Now I can find, by the definition, it should be non-empty. But this is definitely yes. Okay, and in my approach, I use the recursion, and basically my recursion function did two things. So firstly, it returns the maximum path sum going down from the given root, given node. And also, internally, it updates the self.global max path sum. So after the recursive function is finished with the argument given root, now I just had to return self.global max path sum. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.